And I am your host, JEFF, a Cosmic Bard over on Twitter/X. And this is, God, can you believe it? This is episode 80, the final episode of season 4. All season long, we've been pulling on the same loose thread, whether we meant to or not. But those that know me know I am that anal and have been planning this out all season long. I mean, hey, it's true. What can I say? We've looked at civilizations that vanished without explanation, battles that echoed long after they were supposedly over, deaths that refused to stay final, experiments that suggested reality itself doesn't behave unless you're watching it, and histories that collapse the moment you ask who gets to write them. Again and again, a bit of a pattern emerged. Things don't end cleanly. They don't disappear the way we're taught. Uncertainty isn't usually the first causality of a closer look. Tonight, we're going to end this season by turning the lens slightly inward towards those that inhabit this planet. Because it turns out the story of humanity kind of follows the same rules, whether intended or not. Because the first humans were not alone. We shared this planet with other kinds of humans. Now, I'm going to use the incorrect term because I prefer the term I was raised on, Neanderthals, Denisovans, and others whose names are lost in time. And we didn't simply replace them, we lived beside them, we interbred, we carried parts of them forward, which means humanity itself isn't a single line, but a convergence. In this episode, we're going to walk through what modern science actually says about ancient human ancestry, whether the evidence is solid, where it gets maybe a little strange, and where the questions start to outnumber the answers. And then, because this is in the crease, and because, well, this season I think we've earned it, we'll do what we've done all year. We'll ask a careful but disciplined what if. For a very long time, we told ourselves a simple story about where humanity came from. It was a story from a singular point with a beginning, a middle, and then an ending. A story where progress moved in a straight line. Primitive ancestors gave way to smarter ones. The tools improved, brains grew. Eventually, modern humans, bam, arrived, fully formed, unmistakable, and alone. Everyone else, we were told, fell by the wayside. Neanderthals were evolutionary missteps. Denisovans were barely worth mentioning, and other humans forms that existed briefly then vanished. We survived, they didn't. End of story. Oh, we got to admit that version of history is neat, it was teachable, and it fits nicely into timelines and diagrams. It also depends on something we didn't have until, oh, really recently, and that's ignorance on the matter. Because once we learned how to read the biological record, not bones, not artifacts, but the quiet molecular ledger carried inside living people, the story began to unravel, and it began to unravel very quickly. Not dramatically, but not at all at once, but quietly, but it did. The first cracks appeared when science began extracting DNA from ancient remains. This was not supposed to work. Genetic material degrades. Time erases all information. Tens of thousands of years should have reduced these samples to noise. Instead, patterns were formed. Fragments of genetic code recovered from Neanderthal bones didn't look alien. They didn't look distant. They looked familiar. Very familiar. Maybe even uncomfortably familiar. When those sequences were compared to modern human genomes, the result wasn't separation. It was something they weren't quite fully prepared for. It was overlap. People alive today, real people walking around, breathing, thinking, listening, probably voting Democrat, carry genetic material inherited from the Neanderthals. That last bit was a joke. Lighten up. We're having fun. It's the season finale. But these were not curiosities, not genes that we consider defects, as functioning biological instructions that still influence how their bodies respond to the world. And Neanderthals weren't alone. Denisovians, identified at first from a single finger bone in a Siberian cave, left a genetic legacy that appears most strongly in populations thousands of miles away. Their influence persists in regions where survival requires extreme physiological resilience, places where oxygen is scarce and the margin for error is thin. Once again, these weren't rare accidents. They were not isolated events. They were sustained relationships, which immediately break the old stories. Because extinction, as it turns out, doesn't always mean erasure. Neanderthals didn't vanish into a clean cinematic style. There was no final last stand, no single decisive moment where they ceased to exist. Instead, their populations declined, fragmented, and eventually dissolved into others. Their bodies disappeared, their genes did not. And Vincent, I know you didn't catch the beginning. It's Neanderthals because that's how we were taught. We were taught the proper way, not Neanderthals. Has an H in it. I'm pronouncing the H, damn it. Now, the same is true for Denisovans and possibly for additional human groups whose remains we haven't found or maybe haven't even recognized yet. Genetic studies increasingly suggest contributions from hominid populations we cannot yet identify with any known fossils. Humanity's past, not really missing chapters, it's missing labels, which forces us to maybe reconsider what we mean when we say modern humans. In a way, the phrase implies separation, a dividing line between us and what came before. But the evidence refuses to cooperate. Modern humans are not a replacement species. We are more of a composite, a mosaic, if you will. We didn't simply outcompete other humans, we've kind of absorbed them. Uh, And that absorption wasn't neutral. It wasn't random. Certain inherited traits proved useful enough to persist across generations. Immune responses shaped by ancient environments, skin adaptations turned to latitude and sunlight, metabolic adjustments suited to scarcity or coldness. Those traits didn't survive because of sentimentality. They survived. Are you ready for this? They survived because they worked, which tells us something important about the nature of human evolution. It is opportunistic. Human evolution doesn't respect neat challenges and categories. It doesn't care about taxonomic boundaries. It favors anything that increases the odds of survival, regardless of their origin. And that reality complicates another assumption we have often made, that human development unfolded as a steady, predictable pace. It didn't. When genetic data is combined with archaeological evidence, human evolution begins to resemble a pattern of long plateaus interrupted by bursts of change. Extended periods where anatomy, behavior, and technology remain relatively stable, followed by narrow windows where everything, for some reason, accelerated. Now, one of the most striking of these windows appears after Homo erectus. I know, go ahead. Homo erectus. I would make a joke about a certain D&D character, but no one else in the room except for two have witnessed it. Erectus was not primitive. They were adaptable, mobile, and remarkably successful. They controlled fire, they crafted tools, they spread across continents. They endured for more than 1 million years, longer than our own species has existed so far. And then, comparatively quickly, the trajectory bends. Later human populations exhibit significant shifts. Brain size increases, body proportions change, toolkits diversify, social complexity expands, migration patterns become more ambitious, and symbolic behavior begins to surface. The genetic distance involved is surprisingly modest, fractions of a percent. Yet, the outcomes were very dramatic. This is not a case of evolution patiently standing down, maybe sanding down the rough edges over eons. This is acceleration, and I apologize. I have one good eye tonight, so I'm probably going to mispronounce and miss beats here more than I normally do. So please forgive me. But because of small genetic changes can produce large effects, but they usually only happen under certain conditions, and those conditions actually matter. Human populations during this period were rather small. Climate instability repeatedly reduced numbers, creating bottlenecks where chance played an outsized role. Groups split, they migrated, reconnected, and merged again. In such environments, evolution tended to behave differently. Traits spread faster, experiments propagate more widely, innovations don't have to originate everywhere, they only need to move. And interbreeding turns isolated advantages into shared assets, which reframes the way we think about cognitive development. Intelligence is not a single trait. It is not controlled by one gene or even a handful. It is the product of many interacting systems, things like neural growth, energy use, learning windows, stress tolerance, and social coordination. Change the timing on any of those systems, even slightly, and the downstream effects can become enormous. You didn't need a new brain, you needed a brain that developed differently. You didn't need radically new structures, you needed existing ones to operate under new constraints. And this is why regulatory changes matter more than structural ones. Alter when genes turn on and off. Extend childhood learning periods. Adjust how the brain responds to novelty or threat. Evolution doesn't require grand redesigns to produce profound results. It requires sensitivity. And sensitivity can have a habit of cutting both ways. Because the same fragility that allows small changes to reshape a lineage also means we misunderstood those changes easily because we had smaller brains then. We tend to look for intention where none existed. We favor stories with clearer causes and cleaner outcomes. But the human record resists that. The more closely we examine it, the more it resembles a web of interactions rather than a ladder of progress. Once again, contact matters, exchange matters, mixture matters. Which brings us back to a mistake we've made repeatedly, assuming that being human has always meant being singular, and it hasn't. For most of our existence, there were other humans sharing the landscape, competing, cooperating, avoiding meeting, forming families. Species boundaries as we draw them now would have meant very little to people living at that time. What mattered was whether someone was known and familiar, whether they shared any sort of language, behavior, and or trust, and whether they could contribute to their own survival. And let's face it, those relationships tend not to fossilize very well. That said, the consequences do. Every time we identify a functional genetic inheritance from another human population, we uncover evidence of proximity, intimacy, and continuity, which means the question, who are we, cannot be answered without acknowledging who we absorbed. And that realization destabilizes something a little bit deeper. Because if we misunderstood our closest relatives, if we dismissed them as inferior, irrelevant, or extinct in ways that weren't true, then our confidence in tidy explanations should already be shaken to the core. And it's not about distant stars, not about unknown intelligence, not about our own origins. The first humans weren't alone in any meaningful sense. They did live in a crowded human world, a world full of variation, overlap, and uncertainty. Humanity didn't rise because it stood apart, and it endured because it stood together. Because long before we ever wondered whether we were alone in the universe, we failed to recognize how much company we already had on Earth. Now, if human evolution were a straight line, this episode would be over by now. And I know some of you are going, oh, damn, it's not over. No, we got three more acts to get through. But when researchers began mapping genetic change across the human lineage, they expected to see something gradual, a slow accumulation of small differences stretching back through time. That expectation comes from how we tend to imagine evolution. It's a steady pressure, incremental improvement, and constant motion. But here we love the fact that the data doesn't support that picture. Instead, human evolution appears uneven. Long stretches of stability are interrupted by those narrow windows where multiple change clusters are put together. Anatomical shifts, behavioral complexity, technological innovation. These aren't isolated anomalies, these repeat. And if it's one thing repetition teaches us, it's that is a structure. One of the most consequential of these periods often occur after Homo erectus, a species that complicates nearly every simplistic narrative we've tried to tell about progress. Erectus was not transitional in the way the textbooks we once read implied. They were persistent, adaptable, and astonishingly successful. They left Africa, spread across vast distances, mastered fire, developed durable tool traditions, and survived environmental pressures that would have wiped out less flexible species. By evolutionary standards, Erectus was stable, maybe even could say hardy, which is exactly why what comes next is a bit strange. After Erectus, the human story begins to behave differently. Climate or change doesn't just continue, it clusters. Brain volumes increased very rapidly, body proportions begin to shift, tool diversity expands, evidence of symbolic thinking all of a sudden is appearing. And with that, the migration is accelerating, not just outward, but repeatedly. To understand why that matters, we have to talk a little bit about population size because evolution behaves very differently when the numbers are very small. For most of human prehistory, population sizes were tiny, not thousands, not tens of thousands, often hundreds, and sometimes fewer. These groups were scattered, mobile, and vulnerable to climate swings, disease, and resource scarcity. When populations are large, genetic change spreads slowly, variation is diluted, advantage competes with inertia. But when populations shrink, everything begins to change. Bottlenecks, events where populations are dramatically reduced, act like amplifiers to this. Traits that survive a bottleneck can spread rapidly, not because they are perfect, but because the alternative vanish. Chance plays a large role, timing becomes decisive. And human history contains multiple such bottlenecks. Volcanic eruptions. Let's face it, as much as we make fun on Lost Wonder about the so called climate change, volcanic eruptions are abrupt climate shifters. You can have extended droughts, glacial advantages. Each one will reshape the landscape, forcing groups to migrate, fragment, or even disappear in totality. Each one reduced genetic diversity temporarily, and each one created conditions where maybe the smallest of differences could matter enormously. And once again, this isn't speculation, it is well established principle in population genetics. Which brings us to a subtle but critical point. Evolution is not only about traits, it is about the context. A gene that does nothing in one environment can become decisive in another. A behavioral tendency that seems neutral during abundance can turn life saving during scarcity. Flexibility often beats specialization when conditions change rapidly. Consider cognition. Intelligence is often discussed as if it were a unit, something you could either have more of or less of. But the truth of it is a little murkier than that. In reality, it's a network of interacting capacities: memory, prediction, social awareness, learning speed, emotional regulation, and problem solving under stress. Each of these components is influenced by many different genes shaped by development and modulated by environment. Now, that complexity is important because it means small regulatory shifts can have these cascading effects for the benefit of all. Then Say, let's extend a childhood learning window slightly, delay neural pruning, adjust stress response thresholds, modify how novelty is processed. None of these actually are changes that require new structure. None require dramatic genetic rewrites, but together they can transform how the population behaves. And it's this behavior that matters as much as anatomy. Tool complexity doesn't emerge simply because our hands got better. It emerged because brains tolerated experimentation. Migration doesn't expand because legs somehow grew longer. It expands because groups were willing to risk unfamiliar territory. Social systems don't deepen because skulls got bigger. They deepen because individuals can track relationships, intentions, and consequences across time. And this is why periods of environmental instability are actually very important. When the climates fluctuate rapidly, specialization becomes dangerous. Systems optimized for one condition will fail. And the scary thing is, human populations repeatedly have faced exactly that challenge. Ice ages advanced and retreated. Rainfall patterns have shifted. Landscapes have transformed within a few generations. Groups that could adapt behaviorally, so things such as changing diets, tools, and social structures, outlasted those that simply couldn't. And let's face it, none of this requires genius. It requires responsiveness. And responsiveness spreads quickly when groups interact. Now, it's important to note when separate human populations meet, they didn't exactly just, hey, wham, bam, thank you, ma'am, and exchange genes. They exchange strategies, knowledge, behavior, social norms. Genetic traits and cultural practices move together, reinforcing each other. A physiological adaptation might make survival possible in a harsh environment, but it's that cultural adaptation that might make it sustainable. And together, they create stability. And once again, humans are uniquely shaped by that interaction, whether they like it or not. Once again, think of all of this less as a ladder and more like a change in phase. Water doesn't gradually become steam, it reaches a threshold, then reorganizes. The molecules didn't change, the system around it did. And human evolution appears to do something very similar to this. For long periods, nothing. And then, boom. And this is, I think, important because population genetics, developmental biology, and behavioral ecology all agree on a point. Once a system approaches a tipping point, outcomes become harder to predict. And it's these small differences in timing or input that can steer trajectories dramatically. And if you think it's overwhelming at the level of what this is, think about your own life and just what tipping points in your own life up to this date have changed your trajectory one way or the other. You can see it on a singular scale. You can easily imagine it on a larger scale. And this is why the post erectus period draws so much attention. Not because it proves anything extraordinary, but because it represents that window where ordinary process behave in extraordinary ways. And science is very honest about that uncertainty. Now, researchers are still debating why symbolic behavior emerges when it does, why certain technological traditions spread rapidly while others stagnated, why migration patterns suddenly become more ambitious, why cognitive complexity seems to leap rather than crawl. There are some explanations, there are some models. None are definitive. Let's once again, this is not a failure of science. Science is supposed to work this way, especially the more complex something is. So, this failure of science is more a reflection of complexity than it is of anything else. And that is true science. But the deeper we look, the clearer it becomes the human evolution is not a story of inevitability, it is a story of contingency. Change depends on who met whom, on which traits happened to coincide, on which groups survived all the shocks, whether it's climate or viral, and on which one children live long enough to eventually get it on. And that fragility is easy to miss when we look backward from the present. But it does matter. Because once you accept that humanity's trajectory was shaped by narrow windows and very sensitive conditions, you get to take a look at the human race with a different little view. Certainty was never guaranteed. Modern humans are not only the outcome that could have emerged from that period, they are the outcome that did. And that realization reframes every conversation about origins. It doesn't diminish humanity, it contextualizes it. And it prepares the ground for the next step in this episode. Not speculation, not conclusions, but a careful examination of what it means when systems are sensitive, when timing dominates outcomes, and when history hinges on moments rather than movements. It establishes something more important. If change clustered the way evidence suggests, if small differences mattered as much as they appeared to, if humanity passed through multiple narrow gates when survival depended on responsiveness rather than superiority, then the human story is already stranger and more contingent than the version we grew up with. And once you accept that, the next question becomes unavoidable. Not what happened, but how fragile that path really was. And welcome back. I hope you had time to refill your mug, maybe top off your glass, check your doors to see if they're locked, and maybe, just maybe, for your own peace of mind, confirm that your family tree doesn't contain a mysterious, quote unquote, assorted archaic hominin branch labeled with a question mark and a shrug. Because now what we're going to do, well, this part of the episode where the facts are still facts, but the floor gets maybe a little less solid. Up to this point, we've established something that would have sounded ridiculous in a classroom, well, when we attended, or at least when I did, that modern humans carried living genetic inheritance from other kinds of humans. That's not some kind of metaphor. That's the truth. That's molecular. Neanderthals and Denisovans are not just names in a museum. They're contributors. They're embedded in the instructions that build our bodies today. So we have to ask, what's left? Well, plenty. Because the moment you accept that the human story is braided instead of linear, you run into a second truth that is far, far less comfortable. Our evidence is powerful, but it is incomplete. And not because most scientists are careless, but because the past is a thief. Time steals bodies, weather steals bones, earth steals context. And the deeper you go, the more the records behave like a book that has been through a flood, then a fire, then your dog peed on it, and then also, flooded again. But the fossil record gives us shapes and fragments. Tools give us behavior and silhouette. Genetics give us a ledger of inheritance. None of them alone can tell you the whole story. Together, they can get you close, but close is not the same as settled. This is a section where we have to talk about some limits, but not limits as weakness, but limits as reality. First limit, preservation. Most creatures that ever lived left nothing behind that we can touch. As weird as it sounds, fossilization is quite rare. It requires the right conditions, the right chemistry, and the right timing. A body has to die in a way that protects it from scavengers, bacteria, water flows, shifting soil, and the slow violence that is geology. Oh, and did I mention the human equation? Because humans don't tend to die politely in places that preserve well. And for most of the timeline we care about, there weren't many humans at all. Small populations moving constantly, living in landscapes that changed. You can't lose what you never kept. You can't excavate what never fossilized. That means it is entirely possible and plausible that whole groups existed and left almost no recoverable bones. We know this is a possible because genetics keeps hinting at it. When researchers find patterns in modern DNA that don't line up cleanly with no Neanderthal or Denisovan sequences, one honest interpretation is the leading simple one. There were simply contributors that we have not identified yet. No, not mystery aliens, not Atlantis, just humans maybe we haven't met in the record. And no, that isn't a disinformation a campaign by the alien before anyone types it in chat. But the second limit is because behavior tends not to fossilize either. You can measure a femur, you can compare a tooth, you can scan a skull, but you can't dig up a conversation. You can't carbon date the joke because, well, if you could, mine would be very old because I need some new material. You can't hold up, you just can't hold up a friendship in your hand unless she's really, really tiny, but then that just gets awkward. But the things that make humans human, planning, teaching, storytelling, cooperation, symbolic thought, are mostly invisible in stone and bone. Yeah, you do get traces. A burial that suggests care, pigment that suggests meaning, a tool that suggests forethought. But let's face it, even those are interpretations, which is why debates in paleoanthropology can get so spicy. Two teams can look at the same cave and tell two different stories. One sees a ritual, another one sees it practically. One sees art, another sees accidental staining. And here's the kicker that none of them will admit. They both could be wrong because the event happened once, tens of thousands of years ago, and what's left is a tiny smear of evidence that survived a long ago with a very rough journey to reach us. Third limit: genetics, as of right now, are not a time machine. Ancient DNA is astonishing, but it comes with rules. DNA breaks down, it contaminates easily, it preserves better in cold, dry environments. That means we have biases right out of the gate. We have more genetic data from certain regions and climates because those places, oh, I don't know, happen to be friendlier to the preservation of the records. So when we map human history using ancient DNA, we have to remember we are mapping the places where DNA survived. That is not automatically the same as mapping where humans lived. On top of that, genetics tells you that something happened, interbreeding, migration, population mixing, but it doesn't give you the lived details. It can't tell you if it was peaceful or violent. Was this, hey, I'm single, you're single, let's get it on? Or is it beating up the woman upside her head and basically raping her? It can't tell you if this was rare or even routine. It can't tell you whether a child was raised with pride, shame, or absolute indifference. All it can give you is a signature. You still have to interpret the story. The fourth limit: intelligence. Intelligence is a terrible target. Not because intelligence is unimportant, but intelligence is complicated. If you're looking for a single switch, you won't find it. Cognitive capacity is not one gene, one mutation, one moment. It's distributed across many genes and many developmental processes. It's shaped by things like nutrition, social environment, stress, learning opportunities, or for those in Minnesota that didn't understand what I just said, leering opportunities, and cultural scaffolding. So if you ask, when did we become smart? Some will answer, we haven't become smart yet. But the honest, real scientific response should be define smart. And if you narrow it to something like symbolic thinking or language, you hit another problem. Those traits don't leave any clear physical signatures. A skull doesn't come with a label that says, oh, could speak in subordinate clauses in 4 different languages. This is why the record can feel paradoxical. We see the anatomical changes, we see the tools, we see migration, yet the internal experience, the software running the hardware, remains mostly hidden. Which leads us to the fifth limit: timing. Human change clusters and windows that seem rapid compared to the scale we're used to, but rapid and deep time can still mean, hear me out, thousands of years. It's long enough for countless lifetimes, countless choices, countless local events. We can say a shift happened. We might be compressing a complex story into a single stupid sentence. And yes, that compression is useful for teaching, but it can create illusions. It makes the past look cleaner than it really was. It looks like a switch was flipped. And I'll even use Ori's own words here. When a certain side flips the switch, it's not because all of a sudden it's switched. It's because we've been building to that moment. And when we flip that switch, all hell breaks loose. Evolution is messy. We have trends that overlap, populations that diverge, reconnect, and then split again. Cultural changes faster than biology, then biology catches up, and then culture runs ahead of it again. But again, if you want a theme for this entire season, it's that clean stories are usually the ones we tell after the chaos is over. Here's where it does get interesting in my mind. Even within the limits, there are pressure points, places where evidence is so strong to force us to admit, quote, we know something happened here, unquote. even if we can't fully explain the pathway. One pressure point is the spread of specific adaptations. For example, let's look at high altitude survival. Living at high elevation is brutal on the human body. Lower oxygen means stress on the heart, the lungs, and development itself. Yet certain populations, they thrive there. Some of those adaptations are linked to Denisovian ancestry, suggesting inherited variants that helped humans survive these extreme environments. That's not a magic gene. It's not a superpower. It's an advantage that matters when the margin is razor thin. Let's look at immunity, shall we? As humans left Africa and entered new ecological zones, they encountered new pathogens. Immune systems are shaped by local disease landscapes, whether we like it or not. And inherited variants from archaic humans appear to have influenced immune responses in modern populations. Again, this is not being dramatic, not cinematic, just effective. But here's the bit of uncomfortable part that I don't think ever gets talked about enough. Immune advantages can actually be a double-edged sword. A stronger inflammatory response can help fight infection, but can also reduce risk of autoimmune issues. Evolution doesn't optimize for comfort, it optimizes for not dying before you get it on, which is why many inherited traits are trade offs. Survival, if you will, is negotiated on a DNA level. And the third pressure point is development itself. Small changes in the gene regulation can alter growth patterns, brain development, and layering windows for those in Minnesota. If you extend childhood a bit, you expand the time that becomes available for learning. If you delay certain developmental closures, you increase plasticity. And that's not a secret word for make someone genius level. That's more make population more adaptable level. And adaptability is the currency of survival during instability times. So the evidence gives us a picture that has meaningful impacts, and those impacts can spread through population blending. This is established, but it doesn't tell us why certain clusters of changes happened when they did, and the combinations that we absolutely observe. And this is where scientific debate lives, honest scientific debate, something that seems to be a more of passing fancy now. One camp emphasizes climate and ecology. Shifting environments created repeated selection pressures favoring fixable behavior and broad diets. Another emphasizes demography. Population size and connectivity reach thresholds where innovation would spread faster and cultural complexity becomes self reinforcing. But there's another one that emphasizes gene culture feedback. Once cultural practices changes the environment, cooking, toolmaking, shelter, social rules, they create new selection pressures that shape biology. And here's the uncomfortable truth in all of it. They all likely played roles because humans are not a single variable system. They are a storm of interacting forces. And there's probably other factors we haven't even discussed or found yet. But remember, uncertainty is not the same as ignorance. We don't know is not a shrug, it's a measurement, it's a boundary drawn by evidence. And boundaries matter because once you know where the wall is, you know where to press. This is the point in the episode where I want to add a simple thought experiment that stays entirely inside, well, mainstream science, if you will. Imagine you have a fragile system, a small population living in an unstable condition with limited resources, facing recurring climate stress. They're moving, mixing, splitting, reuniting. That system is sensitive to timing. In such a system, a small advantage can matter. A slight shift in development can matter. A minor difference in physiology can make matter. A modest change in learning can matter. And I just go back to a previous ITC two-parter that I did on the bubonic plague as evidence of this. Once again, this is not fantasy, it's population genetics. The reason this matters for our story is that it reframes that count as big in a sensitive window. Big outcomes don't require big causes. And the truth should make everyone, skeptic and believer alike, more careful than certain because it tends to cut both ways. It means you can't point at rapid change and declare it miraculous. You can't point at culture shifts and declare them impossible. Sensitive systems produce surprising outcomes when needing without needing any outside hands. So if you feel as a listener that your brain keeps trying to snap you back to clean narratives, I want you to try to resist it. The path is not a straight road, it is a braided river. Channels are splitting, channels rejoin, and when you look at the delta from above, you can see the whole system shaped by forces you can't reduce to a simple single sentence. One more limit, and then we'll move a little bit more forward. Even the categories are ultimately unstable. When we say Neanderthal or Denisovan, we're using names that feel tidy, but they're labels applied after the fact. They don't capture any local variation, subpopulations, or the possibility that what we call a single group may have been a patchwork of related communities. That same caution should apply to modern humans. We speak as if Homo sapiens are a unified block. In reality, early sapiens were as diverse or diverse as any other human, scattered across regions, separated by distance, shaped by local pressures. They still are. So when you hear we interbreed, don't imagine one dramatic encounter that explains everything. Think of repeated contacts across long stretches of time. Think of borders that weren't lines, but more of zones. Think of a world where meeting another kind of human wasn't a headline. It was a possibility over the next ridge or in the next valley or near the next water source. This framing matters because it turns a story from a duel into a network. And it's important to remember that. It reminds us that evolution doesn't operate on a simple single stage. It operates in neighborhoods with friends and people that know each other. The moment you understand where certainty ends, you can finally ask the most useful question, I think, in this entire episode. What kind of influences could matter in a very sensitive window without leaving obvious fingerprints? Not to jump to conclusions, not to crown a new pet theory, not to turn off your brain, but to do the opposite, to keep it on. Now, that said, I've been very, very lightly handed on this whole thing, but this is an episode of ITC hosted by me. So I'm going to quit dancing around the word alien. Okay, I said it. No lightning strike happened. No FCC alarms are going off that I know of. No one's knocking on my door. And please, before anyone reaches for the tinfoil or the unsubscribe button, let me be painfully clear about what we mean, because I think this is a matter of importance. I'm not talking aliens meaning gods, not looking as aliens as saviors. This is not an attack on anyone's religion or a counter offer to any religion. It doesn't even mean ancient astronauts in a jumpsuit pointing at the pyramids with really big hair. In this term, alien means exactly one thing: non-terrestrial intelligence. That's it. There's no mythology required, no belief system implied, no biology, physics, and curiosity doing their thing. Now, if your instinctive reaction is, that's ridiculous, good. Skepticism is healthy, but skepticism, as we have talked in other avenues in this show, tends to cut both ways. If we're going to dismiss something, the only fair way to do it is by asking harder questions first. Would it even be possible without breaking science? Not did it happen, not is it likely, just this simple question: could it happen at all? Because if the answer is no, it violates known biology, then we're done. We can all go home happy. But if the answer is it's weird, but it doesn't actually break anything, then dismissing this question outright becomes, dare I say, unscientific. So let's build the sandbox properly. First rule, no creation. If aliens exist, they did not make humans from scratch. Okay. That idea collapses immediately. Human biology is too deeply embedded in Earth's evolutionary history. Our DNA shares ancestry with every living thing on this planet. And I know you might go, well, what if aliens put everything? Okay, I'll give you that. But you can trace it all back cleanly. There's no splice point where something foreign suddenly appears fully formed. So, if aliens, as far as human increase of ability exist, they are not our architectures. So, once again, I'm not treading on any religion, okay? Second rule, no wholesale redesign. Evolution doesn't work that way, and neither would any intelligent intervention worth its weight in anything. Massive genetic changes are fragile. They break development. They collapse under select pressure. Even small mismatches in regulatory systems can cause catastrophic failures. Look at how imperfect our recreations of life are on this planet already. Anyone smart enough to cross interstellar space would know that rewriting a genome like a software patch is a great way to end up with a very expensive course. So, for the first time on KLRN radio, I'm going to say patching your shit may not solve the solution. I know somewhere, Lou just got a cringe up and down her spine. Third rule, no miracles. We're not going to have magic genes, no instant intelligence upgrades, no glowing eyes or sudden superpowers. If anything were ever influenced, it would have to obey the same biological constraints everything else does. Which brings us to the only lane where this conversation survives contact with any reality: influence, not authorship. Here is the uncomfortable truth modern biology has forced everyone to accept, if they're being honest. You don't need big changes to get big outcomes if you hit the timing right. Human development is governed less by the presence of genes and more by when they activate, how long they stay active, and where they operate. Regulatory systems matter more than raw material. Timing matters more than magnitude. Extend a learning window slightly, delay neural pruning just a bit, alter stress response during development. None of those requires adding anything entirely new. It requires simple nudging of what's already there. And we know how this works because we see it happen naturally. Look at epigenetics. Environmental pressures can alter gene expression without changing the underlying DNA sequence at all. Those changes can persist across generations. No new genes, no rewriting the code, just adjusting how the code runs. Don't believe me? Look at CRISPR. We're already experimenting carefully, imperfectly, with targeted edits that affect regulation rather than structure. We can turn genes on and off. We can modify expression levels, and we are nowhere near interstellar capability. So let's slow a panic response maybe for a moment. The question isn't, could aliens add a gene for intelligence? You're asking the wrong question. The real question is actually far more boring and far more dangerous to certainty. Could a sufficiently advanced intelligence make a small regulatory change during its sensitive evolutionary windows without leaving an obvious fingerprint? Well, this is where things get quite interesting because now we're not talking about super science. We're actually talking about something no one ever mentions when they come to ancient alien theory and the change of humans. We're talking restraint. Because restraint is the hallmark of competence. Now, let's anchor this with what we already know happened. Multiple human species coexisted, they interbred, they exchanged traits. This is not speculation, this is simple genetic fact. Neanderthal and Denisovans weren't strangers passing in the night, they were neighbors, sometimes rivals, sometimes getting it on. Their DNA persists because it was useful enough to survive selection pressure. And this happened during a period when human populations were small, mobile, and vulnerable. Exactly the conditions where small changes spread fast. This is critical. In a large, stable population, a minor advantage can disappear into noise. and a bottleneck population, it becomes dominant in just a few generations. This is not, once again, exotic science. This is basic population genetics. What means that if, and this is a very careful, if any external influence were to matter at all, it would only matter in a narrow window like this one. Not everywhere, not always, not dramatically. Just once, just enough. Now, let's address the obvious objection. What about compatibility? Okay, fair question. We already struggle with compatibility between species that share recent ancestry. Organ transplants across species are risky. Immune rejection is brutal. Genetic incompatibility causes developmental failure all the time. So, how could anything non terrestrial interact with human biology at all? Uh, if you want the most uncomfortable answer, it probably couldn't, unless it happened to be similar. And similarity matters more than origin. Elsewhere in the universe would still be constrained by chemistry. Carbon based systems aren't necessarily arbitrary. DNA, like information storage, isn't arbitrary. Evolution favors solutions that work, not ones that are novel and weird. If life arose independently but under similar physical constraints, convergence becomes plausible. Once again, we're not looking for a guarantee, we're looking for plausible. And here's the part people don't like to hear. Alien does not automatically mean radically different. It just means not from here. Now, would a species with 99.9 genetic similarity to humans be likely? We have no freaking clue. The odds are yes, but we have no clue. But we do know this, even within our own lineage, small genetic differences produce dramatic outcomes. The genetic distance between Homo erectus and later humans is fractions of a percent. Yet, we know that behavioral changes are enormous. So let's not pretend that big outcomes require a big difference because they don't. They just require leverage, which once again brings us to the most important part in this entire act. If an advanced intelligence wanted to influence another species without ruling it, without revealing itself, without destabilizing development, it would do almost nothing. It would not add traits, it would not create dependency, and it would not leave any artifacts. It would look indistinguishable from natural variants once enough time passed. Because time is the perfect accomplice. After hundreds of thousands of years, selection pressure smooths everything. Novelty is sanded down. Origins are erased. What remains is just functionality. And function doesn't care where the idea actually came from, only whether it works or not. That's why absence of evidence is not evidence of impossibility. It's evidence of time doing what time does best. Well, once again, let me be explicit about something before it gets misused or I get brought into some kind of weird tribunal. Anyway, this does not mean aliens intervene. This does not mean aliens guided evolution. It does not mean humanity was engineered. What it does is something far more modest and far, if I dare say, more unsettling to uncertainty. The rules of biology do not forbid subtle influence. That's it. And once you can accept this, the conversation can change because now skepticism has to do the real work. It can't just laugh and walk away. It has to do, well, it has to explain why something is impossible, not merely unfamiliar. Now, here's where I get to have a little fun. I mean, I've been having fun, but I get to have a little more fun because let's just say, hypothetically, if I don't know, I were an alien, I wouldn't show up with a fleet. I wouldn't make any contact announcements. I wouldn't hand out technology like there's some sort of party flavors. That's kind of reckless. I would observe. I would have a podcast or four. I'd look for systems under stress. I'd look for bottlenecks, and I'd look for moments where small nudges could propagate. If curiosity ever crossed into influence, it would be minimal, cautious, and reversible. Think of it less as DNA engineering and more like ecology engineering. Gardeners aren't redesigning the ecosystem, they're removing the constraints. They are adjusting timing. They are altering conditions just enough to see what happens next, and then they wait. Now, zoom out. The universe is old, incompressibly old. Civilizations, if they exist, could be separated by millions of years of development, if not billions of years. The technological gap between first radio signal and interstellar capability may be vast, but it's a blink compared to cosmic timescales. So if intelligence arises more than once, and we don't know that it does or doesn't, then curiosity becomes a predictable trait. Once again, not domination, not conquest, curiosity. What brings us back to the most important word in this entire episode, in my mind, is plausible. Plausible doesn't mean it's true, doesn't mean it's even likely, and it doesn't mean we should absolutely believe in it. And it means the idea survives contact with known rules. And this is and here's kind of where season 4 earns its ending in my mind. This entire season has been about humility. Humility in history, humility in science, humility and certainty. We learned that battles echo when no one is watching. The disappearances don't require answers to be meaningful. That quantum reality doesn't care about our intuition. That humanity's story is messier, stranger, and more crowded than we were ever taught. So let's face it, ending with aliens isn't just a gimmick, it is a mirror. Because the real discomfort isn't the idea that something else might exist. The discomfort is realizing how often we mistake unfamiliar with impossible. And here's kind of a final thought I want to leave you with. If aliens never touched human evolution, the odds are they didn't, then humanity's story is still extraordinary. A fragile lineage navigating bottlenecks, mixing with, well, in the true form of West Virginia, mixing with cousins, adapting under pressure, stumbling forward into consciousness by accident and by resilience. But if the universe is not empty, if intelligence is not unique, if curiosity is a common outcome of complex systems, then the most alien thing in this entire conversation isn't them, it's humans. Their insistence that the universe must conform to their comfort, their reflex to shut down questions that make them uneasy, their habit of treating uncertainty as failure instead of invitation. Science doesn't advance by pretending we know everything. It advances by asking better questions. And sometimes, just sometimes, that means allowing ourselves to say, I really don't think that happened. But I really can't say it couldn't. And that right there is where the magical world of wonder lives. And that's where we're going to leave it. Not with an answer, not with a conclusion, but with a simple pause. Season 4. God, I never thought I'd see the day where I'd be concluding season 4. It has been a ride through battles and goes through history that refuses to stay buried, through ideas that challenge what we think we know and remind us how much we don't. From Knights on the Wall of Malta to the edges of quantum reality. From forgotten human cousins to the possibility that the universe may be far less lonely than we're actually comfortable admitting. I think the season asks one question again and again, sometimes quietly, sometimes very loudly. How certain are we really? And more importantly, what happens when certainty cracks just enough to let curiosity back into our hearts and our minds? But before I go, I do want to say thank you. Thank you for listening. Thank you for thinking along. Thank you for arguing with us in your head, in your car, in your kitchen at 2 in the morning, and especially those that show up for chat. This is this is what the show has always meant to be. Not answers handed down, but conversations we have to keep having. Now we are going to take a short break. When In the Crease returns, it will be rebranded slightly as part of Listening Post Studio with a new home, a new structure behind the scenes. but the same show relatively you've been listening to all along. Now, don't panic. You'll still be able to find ITC everywhere that you have always found it previously. Same feeds, same platforms, unfortunately, same voice in your headphones. Look at it as not a change in the signal, but just a change in the control room. Season 5 is already taking shape. I got new ideas, new angles, new ways to explore the strange, the overlooked, and the moments where history, science, and humanity collide. I'm really thinking if season 4 was about questioning what we think we know, season 5 is going to be what we do with some of that uncertainty. So take the break with us, catch your breath, refill the mug. Once again, as far as Lost Wanderer goes, look up at the sky a little longer than usual. ITC will be back soon. Thank you.